Over the last 4 weeks, a series of 23 earthquakes has rippled through Oregon's Cascade Volcanoes, raising questions and concerns among scientists and residents alike. This is one of the most seismically active periods seen in recent years. But what does it mean? Are these volcanoes, dormant for decades, showing signs of reawakening? Could this be a precursor to something larger, or is it simply part of the natural cycles deep within the Earth? In this video, we'll take a closer look at the seismic data, uncover the hidden forces shaping this dramatic landscape, and explore the historical eruptions that have forever altered life in the Pacific Northwest. What lessons can we learn from the past, and are we prepared for what might come next? Stay with us as we unravel the mystery of Oregon's Cascade Volcanoes and the alarming surge in earthquake activity. The Cascade Range of the Pacific Northwest has long been a region of both breathtaking beauty and simmering geological tension. Recently, however, a spike in seismic activity has drawn the attention of scientists and residents alike. Over the past 4 weeks, a total of 23 earthquakes have been recorded near Oregon's Cascade Volcanoes, sparking questions about the potential connection between this increased activity and the Cascadia subduction zone, a fault line capable of producing one of the most catastrophic earthquakes in North America. The Cascadia subduction zone, stretching from northern California to British Columbia, is where the Juan de Fuca plate plunges beneath the North American plate. This slow but relentless process builds immense pressure, occasionally releasing it in devastating megathrust earthquakes. But could this tectonic activity also be influencing the volcanic systems of the Cascade Range? The answer lies in the intricate interplay between tectonic forces and magma systems buried deep beneath the surface. Oregon's Cascade Volcanoes, Mount Hood, Mount Jefferson, Newberry Volcano, Crater Lake, and the Three Sisters are part of the larger Cascade volcanic arc, a chain formed by subduction-driven magma generation. These towering giants have erupted spectacularly in the past, leaving scars and legacies that define the region. Could the recent seismicity signal that they are stirring once more? Mount Hood, Oregon's tallest peak at 11,250 feet, 3,029 meters, has shown the most significant activity in recent weeks, with 14 earthquakes recorded. Visible from downtown Portland, Oregon, the towering glacier-clad peak of Mount Hood stands as both a symbol of beauty and a reminder of nature's power. While today this iconic stratovolcano is a haven for skiers and hikers, its history tells a much more volatile story. If one had visited the region during the 18th or 19th centuries, the site might not have been so tranquil. Over the course of 16 distinct years in those centuries, Mount Hood experienced small but significant eruptions. These events sent plumes of ash into the sky and unleashed destructive forces that reached far beyond the mountain slopes. One particularly striking example of this destruction lies in the year 1781. Miles away from the volcano, 32 miles to be exact, a stand of trees met their demise. These trees were not felled by fire or disease, but were completely buried under a 14-foot thick wall of sediment carried by a powerful lahar. This volcanic mud flow, fed by melted glacial ice and volcanic debris, surged downriver with such force that it exceeded historical flood levels by a full foot. Later erosion revealed the eerie graveyard of trees, a stark reminder of Mount Hood's destructive potential. Lahars have long been a hallmark of Mount Hood's eruptions, driven by the intense heat of volcanic rock-melting portions of the mountain's 380 million cubic meters of glacial ice. These mud flows have swept through regional rivers time and time again, reshaping the landscape and threatening human settlements. One such area, Troutdale Airport, is built atop ancient lahar deposits and could once again face devastation if a similar event were to occur, With approximately 7,500 residents and numerous businesses in the vicinity, the risks posed by future eruptions are undeniable. Mount Hood's most recent eruption occurred in 1866, solidifying its status as a very high-threat volcano, ranking as the sixth most hazardous in the United States. Like other peaks in the Cascade Range, Mount Hood owes its existence to the subduction of the Juan de Fuca Plate beneath the North American Plate. This tectonic process generates magma deep within the Earth, which occasionally rises to the surface to fuel volcanic eruptions. Geologically, Mount Hood is an ancient volcano with its origins tracing back 500,000 years. Its earliest eruptions occurred across a series of vents scattered over a 5-mile-wide area, producing thick andesite lava, flows that formed the volcano's base. Eventually, activity became concentrated at a central vent, creating the classic stratovolcano shape through alternating layers of ash and lava. Around 100,000 years ago, Mount Hood experienced a catastrophic collapse, obliterating its summit and much of its northern flank. The debris avalanche from this event covered vast stretches of the surrounding terrain. Over the next 70,000 years, subsequent eruptions rebuilt the volcano, restoring it to its former height. The addition of andesite and dacite lava domes at the summit continued to shape Mount Hood, while periodic dome collapses triggered pyroclastic flows that swept down its slopes. One of the most notable periods of activity began around 1,500 years ago, involving two multi-decade-long eruptions. These events not only created lava domes, but also generated deadly pyroclastic flows that traveled up to 7.5 miles from the volcano. During this time, the southern edifice partially collapsed, forming the scar where modern activity has since occurred. The summit's most recent dacite lava dome formed during eruptions between 1781 and 1793, followed by further eruptions in 1859, and again from 1865 to 1866. Mount Hood's eruptive behavior is characterized by long intervals of relative quiet, often lasting centuries or even millennia, punctuated by periods of frequent activity. The volcano has now been silent for over 150 years, suggesting it may be in another dormant phase. However, the unpredictable nature of volcanic systems means that this could change without warning. Oregon's tallest peak stands as a reminder of the delicate balance between nature's beauty and its potential for destruction. Though it is currently quiet, the evidence of its past points to a future where Mount Hood could awaken once more, bringing with it the same forces that shaped its striking glacial-covered slopes. Mount Jefferson, standing at 10,502 feet, 3,201 meters, recorded 3 earthquakes. Mount Jefferson, Oregon's second tallest peak and a strikingly glaciated volcano, stands as a testament to the volatile forces that shaped the Cascade Range. Situated 50 miles south of Mount Hood, its snow-capped summit may appear tranquil, but its history tells a story of dramatic eruptions and geological activity. Although heavily sculpted by glaciers over millennia, Mount Jefferson has erupted 3 times since the end of the last ice age, with its most recent eruption occurring just 1,000 years ago. While some evidence suggests it may be entering a dormant phase, Mount Jefferson remains classified as an active volcano, and its potential for future activity cannot be ignored. The iconic stratovolcano that bears the name Mount Jefferson is only the northernmost feature of a larger volcanic complex. This expansive region spans 11 miles in length and 5 miles in width, encompassing lava domes, once active subglacial vents, and cinder cones that erupted briefly before becoming silent. The southern part of this volcanic area has been the most active in recent times, hosting all 3 eruptions of the Holocene epoch. These events occurred at separate cinder cones collectively blanketing over 8 square miles with fresh basaltic and andesitic lava flows. Should Mount Jefferson erupt again, it is most likely to originate in this southern region, potentially forming another cinder cone. Newberry Volcano, a massive shield volcano that encompasses a caldera, also saw 3 earthquakes. Newberry Volcano is an immense and ancient volcanic structure covering an area of approximately 1,200 square miles. Slightly larger than the entire state of Rhode Island, this massive shield volcano is characterized by its dual nature. It has produced both highly fluid basaltic and basaltic andesite lava flows and powerful explosive eruptions. Its activity is the result of at least 2 distinct magma chambers, each contributing to different eruption styles. The summit eruptions are known for their explosive intensity, creating features like the Big Obsidian Flow and the 2-stage caldera, while flank eruptions produce vast lava fields through more effusive activity. One such flank eruption occurred in 550 BCE when lava from the lava butte cinder cone spread rapidly across 9 square miles, reaching areas near the modern community of Dutz River Woods, now home to 5,800 residents. The lava flows from Newberry's eruptions can travel at speeds of up to 30 km/h, 18.6 pars, quickly covering large areas in molten rock. Despite the volcano's last eruption taking place in 690 CE, Newberry has maintained an average eruption frequency of roughly 1 per millennium during its geologically recent history. The caldera at Newberry, now hosting the twin lakes of Paulina and East Lake, was formed through a series of catastrophic events around 300,000 years ago. The volcano experienced a major explosive eruption 19 times larger than the 1980 Mount St. Helens event. This eruption released a massive volume of silica-rich material, significantly reducing the volcano's height, which had previously reached a towering 14,000 feet above sea level. The collapse created an expansive crater, or caldera, which was further enlarged by another colossal eruption 75,000 years ago. The caldera's interior has since been shaped by subsequent eruptions, which were relatively less violent but still substantial. Outside the caldera, volcanic activity has predominantly aligned along the Northwest Rift Zone, a region defined by a series of fissures trending north-northwest. This rift zone has been the source of numerous eruptions, ranging from purely effusive lava flows to mildly explosive events, contributing to the elongated shape of the modern volcano. Newberry's growth is attributed to its high eruptive rate and ancient origins, with activity spanning at least 600,000 years. Its eruption rate has been approximately 3.6 times higher than that of Mount Rainier and 73% higher than Mount Adams.